We're going to talk about containers, so the rise of containers and the effect that that's having on not only the developer world, but specifically the operations world. So I call it the ops dev world, so the inverse of DevOps. So just a little bit about my background. I am the CTO and co-founder of Cumulus Technologies. We're a boutique consultancy, and we focus on enabling people to actually get the most out of cloud, both from actually building clouds, but also understanding how their developers are actually consuming clouds and how that can actually be done more efficiently, looking at the overall picture of the situation. Part of our doing that is, of course, providing training, providing this kind of information out to the community as well. So we provide training classes on top of just helping people understand how to leverage and use cloud. Obviously, you see Twitter handles and our website. We have a blog that we keep up to date. We also have a newsletter that we put out on a basically weekly basis, where we cover topics at much the same depth as the conversation we're going to have today. If you guys feel like it, I love questions. So please ask questions during the session. If you aren't quite comfortable doing that, you can go ahead and hit me up on Twitter. Ask a question there, and we can at least keep the conversation going throughout the session, all right? And even after, hopefully. Keep chatting, keep talking. So we're going to talk a little bit about containers. This is Containers 101, so I figured I'd do just a quick overview of the history of containers, sort of the development worldview that sort of came from containers. We'll look at why containers have become such an important part of the development community today, sort of what has driven people to start using containers versus the virtualization technologies that were so prevalent even a couple of years ago. And then we're going to look at a big shift in how containers are being consumed, specifically mapping that to the OpenStack space. And we'll talk about a little bit about how OpenStack works relative to containers and how OpenStack actually wants to start using containers going forward as people look at operating container-based OpenStack. Kind of an interesting different approach to these things. So first of all, when we're talking about containers, we're talking about Linux containers really more than anything else. That doesn't mean that you can't containerize an application from a Windows space and run that on top of your container environment. But I'm thinking about it, again, my background, I come from the operations space. I come from looking at how you actually get these applications up and running, how you get the services that make these containers actually happen. We're also looking at containers as a segregation model, right? Containers really, when I look at it, I see something that helps me wrap up a process and manage the segregation and restriction to that. And really what we're looking at is a technology that's using two key components within a modern Linux kernel, C groups and namespaces. These are the technologies that make containers work today. So if we look back, I think of containers as coming from the time where people started to timeshare a single computer. As they started doing that, they realized at some point people started hacking each other's accounts, right? They were able to realize, hey, I can see other people on the system. And so the operators, the systems developers at the time started to provide segregation. They said, well, why don't I make it look like when you're in the system, the only thing you can see are your environment components. And this goes way back to the 60s and 70s even, so that far back into history in making this possible. That capability was added into the Linux environment. Specifically, it started with BSD. The BSD community built this concept of jails, which provided that view. It was a restricted view of your process environment. Solaris actually implemented a similar function, and around the same time, this was about 15 years ago or so, providing a similar sort of segregation. And it was really focused on the application processes. And so from an application developer perspective, the application developer really didn't need to worry about anything because they saw an environment that looked just like any other operating system they were running their applications on top of. But from a systems administration and operations perspective, there was segregation. There was resource management that could suddenly start to happen here. LXC was a big change in how that happened, and the LXC world and really sort of the container world got a big boost with Google starting to really push into this space, realizing that they were starting to containerize their applications, and they started working with the Linux community to actually do that. The Linux community that seemed to stand up the most, at least the one that sort of presents themselves as having stood up the most, is the Ubuntu canonical community. Those folks started working with the LXC technology, or Lexi as it tends to be called. And so they built this model for managing the containerized application process, which effectively took an operating system and potentially stripped out some of the pieces that weren't needed, but you still had what looked like a full operating system. And even today, if your application needs a lot of the services of an operating system, an LXC style container might make sense. At the same time, well, not the same time, just recently, in the last 2 or 3 years, the folks at Docker said, you know, we can take all of these containerized processes, this model that Google is presenting as a great way to actually run our distributed applications, and make it a little easier. There's some problems that they saw that they wanted to address in the containerization space. And I said, well, if we simplify this, if we make it easier to build out containers, they created this concept of a Docker file, a description of the steps you need to actually get your application process running. Right? And if you can describe that basic set of steps, you can now create a little container that doesn't have all the complexity of deploying these containers with LXC. Now, the LXC community will say, hold on, we can do that too. You can start from a base model and start to build up from that too. So this is true, but the Docker community managed to get the developer community to really buy into their model because it simplified the application deployment process. If I needed to take my application code and get it running on a server, I could follow this simple Docker model, this little file that described how I deployed things, and get the system up and running. So very big change and a very powerful change. The other thing that I had on that slide, which I think is also important, is the registry. Now, it sounds like actually the next session is going to talk more deeply about the actual registry and some of the interfaces that you have into that. The registry was another key component of this. Suddenly you had a way of actually creating these containers and posting them somewhere that you could pull into another machine. So when you start thinking about continuous deployment of your containers, having a central registry is also a very important aspect to this. So containers are really important, but you know, why do we need this? Why don't we just stick with virtual machines? From an operations perspective, I know how to manage a virtual machine. I know how to manage the operating system around the virtual machine. The real difference is that a virtual machine is effectively a full-on computational environment, and all of the complexity that goes with that, including all of the security management that goes with that, is a part of the operational complexity that you get with virtual machines. Right? With the container, there are some inverse security issues. The containers have a single shared state interface with the local Linux kernel that they're running on top of, and that can be, in some instances, a potential security issue. But at the same time, you have reduced the overall security boundary of your application and the way your application presents to the world because you've limited its ability to see into the rest of the Linux system. So you no longer have to worry about somebody else's application creating a security vulnerability in your application space. So in that case, it's actually very powerful. So really, containers are process boundary management, whereas a virtual machine is an operating system boundary management tool. Right? So that's a way of thinking about these things differently than I've seen people talk about in the past. So a couple of other key things that drive people into the container space. If you're developing an application and you want to test that application and you want to say, well, I'd like to have a new clean machine so that I understand if my application is going to work in that newly deployed environment. Right? It often takes minutes, if not even many, many minutes, like a half hour or more, to get a virtual machine spun up. Or a physical machine brought online. Well, in physical world, I mean, one of the classic issues was it might take me 3 or 4 months to get a physical machine brought online because I have to acquire the thing first, right? But the cloud space, the on-demand space, at least made virtual machines fairly easy to spin up, but it would still take minutes. And then you have to install all of the services that you require on that newly minted virtual machine to actually get your application up and running. And there are a number of tools, the CAPS tools, the Chefs, Ansible, Puppet, SaltStack, or the current set. These tools were available to actually enable the automation of that bring up of your operating system. Well, Dockerfile is effectively a lightweight version of that, if you want to think about it that way, right? It describes how to turn your application on, but without the rest of the operating system. So I no longer have to worry about spinning up an NTP instance so that my time is in sync on the underlying operating system. That's handled by something else, right? So a lot of value there is just this focus on just focusing on your process rather than all of the other operational complexities of getting a system running for your application. And when you start thinking about distributed applications where you might want to have hundreds of these systems, it becomes even more pertinent and more important. So agile development is another key driver behind all of this. Right? If I want to start developing in this agile fashion, be able to spin up an instance whenever I get started or spin up lots of instances to test something, then get rid of them when I'm done, the minutes that it takes to spin up a VM suddenly becomes a significant portion of turning my application on. If I can actually do that in a second or less, and do that for hundreds of containers in seconds or less, that becomes incredibly compelling. And I'll talk a little bit more about that when we start talking about OpenStack on top of containers too, because that's where I have some very specific experience. So developers really don't love operations. So this concept of DevOps is important because it is something that has allowed the community of software development engineers to really scale what they're doing. Right? The fact that I can actually turn a virtual machine on in a couple of minutes on a cloud-based service that isn't even local to my actual business is incredibly powerful. It has changed the world of software development for the better. At the same time, the actual operations that goes along with that, again, managing the security of those underlying virtual machines. I keep getting security alerts all the time for things that I spun up a year ago and are actually running service for me, but they're not being upgraded. They're just sitting there static, right? So the operations of those environments becomes an overhead that the developers now have to endure, right? Because the developers own the end-to-end process. This is something that most developers that I work with don't really want to have to do, right? They'd rather manage this at a much higher level. So if I can actually limit my operations to my application, I need to have the latest versions of my libraries, the things that make my application run. I need to have the actual latest binaries or process code of my actual application installed on the machine. I can focus on operating at that level. Now the CAPS tools, that Chef, Ansible, Puppet sort of system space is still an important aspect in helping with that service, but the containerization changes how I actually think about running that process, right? And that's the real big shift. So developers do love containers because they simplify everything, I think. Right? I can now actually use the same container on my local laptop where I can do development and potentially development across many, many containers, not just one, but I can do hundreds of containers very easily. Hundreds of VMs on a laptop is often very difficult because each VM needs a copy of the operating system. It needs a chunk of disk, which often we don't have locally. Right? It also needs a chunk of memory, which often we don't have to segregate locally. With containers, you ask for a resource, but you don't actually have to segregate that resource entirely from everybody else. So I can potentially build and validate much larger systems. And those containers that I've built to do that validation suddenly change how I actually can scale my application. If I want to run a test environment, I can take all of my container models and give them to my test team if I have a separate test team, or I can write my own tests because I'm a DevOps engineer, right? So I have to write everything myself. But I can run my own tests against exactly the same model that worked in my development environment. Right? And I want to take that to production. Maybe I have a staging environment, put it into staging, and I actually start to run some load against my system. I'm still using the exact same containers, the exact same processes. All the code, the way it was all stitched together is always the same. This is huge. This is the big shift that I think the container world has provided to the DevOps community. Right? Now again, as I said, I'm an operator, so I think about this from the perspective of operating these environments. We still have to have somebody managing the underlying operating system. Right? In the slide earlier when I was talking about containers and virtual machines in bare metal, there is still a physical server somewhere. Right? I have a rant recently where I said serverless is crazy because you're still going to run on a server. Right? That wasn't the point of the serverless community, but they've kind of been presenting themselves that way a little bit, so they kind of left themselves open to that. But I still have a physical server. I'm still going to put an operating system of some nature on that. Now, even if that operating system is stripped down as much as possible just to run containers, it's still an operating system. It still has a security attack vector. I still have to continue to manage that. Somebody still has to operate that layer of my environment. Right? I can pass that off to a platform as a service company or a container as a service company, Google, Amazon. I mean, there's some big companies providing that kind of service. But I still have to have somebody managing that resource. Right? And when we look at what that starts to look like, all of the other services that sit around this, it's not just about the container. Right? And we're seeing in the Docker community, the Kubernetes community, and a number of the other companies that are springing up in the container space. I think Apsara also falls into this category. You know, we're seeing people start to realize that there's more to running an application in a containerized environment than there is to just thinking, oh, well, I don't have to operate the system anymore. Right? So there still has to be somebody running the ops. And what we're seeing is that with all of the different container models, and there are some variants to how you actually run a container, even though they're all using the exact same kernel functions and services, the actual process of turning a container on, enabling it, that is a little bit different between every one of these solutions. We're seeing some kind of pairing between services. Now, most folks that build container operating environments, that's at least the way I've been starting to describe these, and I'm hearing others as well. Container operating environments are those sorts of things that help you manage not just one container, but hundreds of containers. Not just one container, but a group of containers that become a process entity, right? And so that's where you see the Kubernetes, the Docker Swarm, and Docker Cloud class services. We're seeing operating systems for running containers plus the management for them, things like Rancher and CoreOS and services of this nature that are coming along, providing that next level of systems operations. right? Now, they're also trying to provide, CoreOS, for example, is an interesting one because it automatically upgrades itself. If there's a security vulnerability that the CoreOS guys find, they post it. The CoreOS system that's running, as long as it has internet connectivity, will update itself and get the latest version of services. And that's created some turmoil amongst some in the operations community because they don't like the loss of control that says, well, somebody else is going to make sure that you're upgraded, right? And actually, the developers also have to think about what that means for their application. If their application is a single container that expects to always be on, well, first off, they're probably thinking wrong about their operating environment. But they're going to have to deal with some changes, especially if they end up running on a CoreOS environment or an environment that sort of handles these sorts of things. Now, the management functions that these operating environments provide are actually really important. Things like lifecycle management, rolling upgrades. You know, if I have 100 VMs or 100 containers running, I might not want to turn them all off and turn on a new set of 100. I might actually want to turn some on and selectively load balance traffic to those new containers to make sure that they can actually handle the load as the system sort of takes over. Managing that is a lot of what these container operating environments start to provide, is a better set of tools for managing your application. So we're not really still operating the underlying infrastructure, right? There still, I think, is a gap here. But the tools for actually managing your application, scaling your application, supporting the scale of your application really are the things that are coming along. So this leaves me open to talking about OpenStack, which to me is still a very important part of the data center world. I see a lot of buzz around the fact that OpenStack is dead, nobody cares about it anymore. Well, I still care, so I guess one person cares about it still. But I think OpenStack is a technology that really still has a lot of value because it provides a consistent model for managing infrastructure. Right? It can also provide a consistent model for managing containers, but it's still that consistency, much like the Docker file format and the layered file system that come along with the Docker model for managing containers is important and consistent and is now part of a standard, the Open Container Standard. Right? The OpenStack services provide a standard that maps very well to a lot of other online services, a lot of cloud infrastructure as a service services that actually provide a similar kind of functionality. So when I think of OpenStack and managing containers, I actually see two different model spaces. And apparently it said I need to talk about myself again. Oh no. Docker wants to update? No. Well, that's interesting. I like it. It's a cool tool. You want to see how to do that? Yeah, exactly. We'll spin up a container. Yeah. Well, that's easy. What you do is you say upgrade, and then you have to pass. No, anyway. So when we think about managing containers, there really are two aspects to what OpenStack can provide. Now, OpenStack in this world thinks about infrastructure as a service. Infrastructure as a service really is thinking about compute, network, and storage components of a data center, potentially virtualized, not required, but potentially virtualized, and managing them to do some function. Well, from an operator's perspective, one of the things I can do is I can use that OpenStack system to deploy one of these container operating environments. So I can deploy the Docker Swarm class capability across a cluster, or I can deploy Kubernetes for a system, or I can deploy a bunch of CoreOS components and then maybe layer Kubernetes on top of that. Right? So this is one model, and what I would then end up doing is giving my end users access to that environment, whether it's a Docker-based interface or a Kubernetes-based interface, or even potentially access to LXC. That's a little bit trickier because there isn't quite the same sort of distributed approach to managing containers in an LXC environment today. I think will change over time. That's one approach. The other approach is I can use OpenStack infrastructure as a service and provide a set of models for which my end users can deploy their own container operating environment. Now again, most developers don't really want to run this themselves. Their whole point is I'd like to focus on my application because that's where we're going to make money and the business is going to grow and we'll be happy, rather than actually having to deal with some of the underlying components. But in some companies, especially at larger scale companies, there still are questions about whether you want Docker or whether you want Kubernetes, or should I put Rancher on the system and run it that way. So giving your end users flexibility might be appropriate depending on the size of your organization. Infrastructure as a service tools let you do that. OpenStack lets you build that in-house, right? And if you have big enough scale and you have enough consumption of resource, OpenStack makes a lot of sense because it gives you flexibility for deciding what you're going to do. Maybe eventually you say, well, look, we've tried all these different things. We've got projects running on all of them. We're all using at least Docker container models as our base container model. We're going to go with an all Kubernetes solution as our management layer. And I move from my second model to my first model, and I just provide one service that I as an operator can manage, right? There is one other model for where containers and OpenStack cross, and that is running OpenStack in containers. Because OpenStack in reality is a containerizable application. It is just software. It's really middleware that deals with end user requests and maps them to some kind of infrastructure, physical, virtual, otherwise, right? And so these two things sort of really come together. So when we think about running containers on OpenStack, you really have to sort of think about where you're going to run them. And one of the nice things about OpenStack is that as of today, well, as of a couple of years back, but really today you have a choice. You can use virtual machines, or you can actually deploy onto bare metal, right, or layer Kubernetes plus Docker or Kubernetes plus Rocket, right? So there are a number of different ways of actually managing that infrastructure, but it's sort of defining what that is. And again, with the infrastructure as a service engine in OpenStack, you can actually enable that service functionality. You can enable those connections between the two different components. The other thing is, how are you going to launch your containers? At one point, you could actually even provide a catalog service. So there are some extensions to the OpenStack environment, part of the big tent model of OpenStack, which is all the services that aren't considered basic infrastructure services that provide catalog-like functions. So you could actually deploy a Kubernetes environment and then create catalogs of Kubernetes-based services that get automatically launched by an OpenStack service in an application-driven model. Right? So there are some different ways of actually using the infrastructure service to actually consume the resource. Right? You could even deploy a Cloud Foundry or OpenShift platform as a service environment, which under the covers tends to use container services, containerized services, but to the end user is just a way of managing your application code. So rather than containerizing it, I'll just give you the code directly and you go put it into a container for me. I don't have to deal with that anymore. Some people like that model. Some people still like the control of containers. And with something like an infrastructure as a service layer underneath, I can provide you bare metal, virtual machines, containers, or even container operating environments, or lastly, platform as a service offerings, all from the same base hardware. So there's a lot of flexibility that an OpenStack class environment provides to container-based solutions and container-based systems. So on top of just the application, because I think most of us think about these things in terms of applications, there are other services that we also have to think about. What's your storage model? What kind of network functions do you actually need, right? Most container operating environments do include at least a modeling for load balancing. Classic part of scale. Hey, if I'm going to help you manage 100 containers, maybe I need to manage the front end that gets you to those 100 containers in an equivalent and distributed fashion, right? One of the nice things is that infrastructure service offerings, again, OpenStack is my infrastructure as a service offering, provide engines for actually managing load balancing. So I can actually map that in. Again, maybe if I want every tenant to have their own container operating environment, I can also map in the load balancing aspect into that same system. So now I can distribute load balancing as a part of that service, and I can do that within the network where it's maybe more efficient. Right? So there's a scale component to this. Storage is the same question. In the classic model, if I as a developer were to take a physical server and deploy a container operating environment on it, I would probably just end up using the local disk as the volume that my containers deploy on top of. But with an infrastructure service, I actually have the ability to say, well, maybe I'm going to use third-party storage, external storage, or distributed open source-based storage like the Ceph technology as a storage engine, right? And I can then map that into my container environments. And now I actually have the ability to have distributed storage as a part of my containers. And this is important if any of you have actually tried to run a database that might spin up on any of multiple hosts. Having a distributed backing store is really important because then my database can always talk to its actual storage container. Kind of important if I want to run a persistent database. Just something to think about, right? So these components are also kind of important. Another thing, and this is one that I think there's a lot that still has to happen in this space. Scheduling is an important aspect of any system. Whether it's your own application, how many do you want to turn on, when and where? Do you want to put them in multiple data centers? How are we going to deal with that sort of placement? Infrastructure services have the exact same question. Where am I going to turn a virtual machine on? Where am I going to provide you access for a container? The thing is that right now we're seeing lots of separate scheduling services. And OpenStack has not fixed this, by the way. This is not something that I can say, oh, OpenStack resolves all the problems. OpenStack has schedulers for its compute, has schedulers for its network, has schedulers for its storage components. But this is an area where people are starting to look at distributed schedulers, something like the Mesos scheduler, for example, as a potential solution. There's still some questions about how that might actually fit together. But having one scheduler that an infrastructure service can talk to and potentially the container services can talk to is really going to change how all these services get deployed. There's a lot of work going on just in terms of packing resource into physical machines in the virtual machine space, and the same I think needs to apply in the container space. The last thing that you want to do is to have to start doing the exact same thing people do in the VM world, where you spin up a virtual machine, then you run a little performance test on it to see, well, am I actually going to get even 1 core's worth of performance out of this, or did somebody else just manage to hog this entire physical server, right? Well, I don't want to have to do the same thing with containers, spin up a container and see if my process is actually responding in a reasonable time frame to make that a reasonable container. If not, kill it, try again, and kill it and try again until I actually get a set of containers that are meeting my own SLA for service response, right? The scheduling is a core part of that, and it has to go all the way down into the infrastructure. We need to understand what the infrastructure is doing to make this work, right? So, lots of these sorts of things. People are talking about sort of single layer management. Well, we'll just use an all Docker environment or all Kubernetes environment, and that's it. We'll never use VMs, we'll never use bare metal. That's completely unrealistic, right? Like I said, if you're going to run databases in containers, then you really have to be aware of what you're doing, which means you really suddenly have to understand the infrastructure. And if it were my application that needed to scale, I guarantee you I'd be deploying my applications either as my databases either as bare metal systems or worst case virtual machines. Because there I have control over what becomes my data store for the entire application space, right? At the same time, the rest of my application, the applications that are being developed on top of that data store, yeah, containers really make a lot of sense. I just started really working with one of the OpenStack containerization solutions, this technology called Cola. And it's completely shifted my visibility into understanding how containers work, because it used to take me 2 to 3 days to get an OpenStack system up and running. With this, by containerizing just the control plane, now in this case it also is trying to containerize the database. That's something I have to work on. But even with doing that, I can turn an entire system on in 3 minutes. That's a pretty big shift, right? That really changes what that application, that infrastructure middleware application can do for me, right? Because if I need to change what it's doing, it's not, oh, well, let me rip this entire system down and rebuild it. No, it's, let me just restart a service. Let me update a component. Okay, maybe I have to migrate a part of my database to actually deal with some new capabilities, but I have that ability to do that in a much more rapid fashion, right? So there's really some important capabilities there. And lastly, before I jump into the other version of OpenStack, I think the per tenant management aspect is something that's out there. People have talked about it. There's even a project that we'll talk about in a second, specifically focused on managing containers as services for teams. I think that's going to add complexity to the overall environment, right? It is certainly possible, and people are doing that, right? People are saying, look, whatever you want to deploy, I understand, we're a big company like a GE, and everybody's going to have a different opinion, right? And you've got lots of real smart architects, and you've got lots of real smart operators that are going to manage that. But from the perspective of actually helping manage a solution and manage the services that go along with the solution, it makes sense to pick one. Try it. If you're containerizing your application and building models around that in one of the container operating environments, so like Kubernetes has this concept of a pod, which is a set of containers that then gets mapped into a service and it gets mapped into a replication controller. Great. You've sort of decided on some of the application management, so the application operations that you're going to have to deal with, right? Moving that to a Docker environment can be done, but you're going to then have to translate between one and the other. Now, I look at this as translating between an Amazon environment and an OpenStack environment, or an Amazon environment and a Google Compute environment, right? I actually had people at one point say, well, we can't move, we're all in Amazon, we can't move to a private cloud even though it would be more cost effective for us because it's just going to take us too long to actually translate all of the operations that we've built into Amazon, where they weren't doing anything really crazy. They were just spinning up a bunch of VMs and managing load balancing. But we can't move that into an OpenStack environment. And so in 3 hours we did. And that's because really the models are similar, right? The systems models are similar. But it still, I think, makes sense to pick one model, support it. Your entire organization does better because everybody gets an understanding of the different resources. Now, the other thing is that OpenStack really is a distributed application. Some folks I've talked to say it's not really a well-designed distributed application, but really it is. And there are 3 different layers of OpenStack. There are all the OpenStack services. So Nova is a service that manages compute for OpenStack, right? And that service has a set of sub-services, a number of different processes that run to actually manage compute. All of those processes are stateless. Stateless processes are great in containers, right? Because they're not carrying any state. As long as my database is good, I don't care what happens to it. You know, spin up another one, see if the newer version works better. Doesn't matter. And container models are great for that. So using the container service as a way of modeling OpenStack and deploying OpenStack is fantastic. And we're seeing a lot of interest. Over the last 3 months, I would say 4 or 5 different groups have actually come up and said, hey, we can actually deploy OpenStack on top of Kubernetes. Now, they're also mapping the databases into that because they basically take the entire OpenStack service and are modeling it like that. Maybe that's a little bit much. I think for an operational environment, there are things that I would look at a little bit differently, but you can still do it. It does work, right? I still wonder how people are going to manage database backups and a bunch of other things in that environment, but that's a separate discussion, right? But there is then, if we do say, well, look, I actually really like using a model like Kubernetes or the Docker swarm-based model for actually managing my cluster application, which is OpenStack, there still is the question, well, how am I going to get Kubernetes onto the bare metal or Docker onto the bare metal to actually run my OpenStack? And that's a fun one. I'm working with a number of different technology partners that are helping just that initial bare metal infrastructure setup, because that doesn't go away. I mean, we'd like to think it would go away because, oh, I'm just building containers now, but all that infrastructure still has to exist. It still has to be managed. So we're seeing a little bit of that going on. Now, when we talk about projects, OpenStack is all about projects. It's all about the different groups that are trying to make something happen and map it into the OpenStack community. The project that I've seen that has sort of the most, I would say now, history and potentially support behind containerizing OpenStack as an application space is the COLA project. Like I said, this is one that I've started working with a couple customers specifically to help them accelerate the deployment and upgrade manageability of this environment. This is a 2.5-year-old project, and it's finally getting to the point where I'm seeing it as stable enough to actually use for my production workloads. Now, the COLA project is just using Docker containers, so it's not actually using any of the cluster management services of things like Docker Swarm on top. It's not using Kubernetes yet, and to that end, there are now a number of projects that we'll get back to that. There are now a number of projects that are actually looking at Kubernetes as the management layer, the container operating environment layer for our OpenStack services, right? There's even a COLA Kubernetes project. So even the COLA team realized, oh yes, this actually does make sense. Let's see if we can't use our same continuous integration and deployment models for using Kubernetes as the management layer. In the past, they've been using an Ansible model for that, right? So just real quick in review, right? So we know that containers are segregated processes. Some people call them VM light. I think it's even lighter than that, right? It's just the actual process and maybe some libraries around what you want to do. There are folks that actually do go the VM light route. They actually build effectively an entire virtual machine and then run it as a container in a chroot environment. That's effectively the LXC services model. And there are reasons for doing that. There are definitely times when that's the right approach to this. But containers really abstract the operational model because now the application developer can focus on operating their application. You still need to think about scale. You want to map in load balancing, some of these other services, right? We also know that containers are great for supporting the scale-out model that most application environments want. And all of those functions, all of those features of containers are something that you can deploy on top of an OpenStack environment. OpenStack provides a good infrastructure base for managing the infrastructure components that still need to exist. And lastly, because containers are great for managing distributed applications, it turns out that containers are probably the perfect environment for helping to manage OpenStack as an application on top of your infrastructure service. So there still is the question of which comes first. Do you deploy Kubernetes, or do you deploy OpenStack, or do you deploy OpenStack to deploy bare metal servers that are running Kubernetes to deploy your OpenStack? But we'll get there. Those pieces are coming together, right? All right, well, that's what I had for you guys. I know I talked fast and hopefully kept you awake a little bit.